In this module, we'll discuss other methods that can reduce a welder's exposure to Chrom-6. Using local exhaust ventilation is one of the best ways to reduce your exposure to Chrom-6, but there are other ways to do this. Industrial hygienists rank exposure controls from the most effective to the least effective in what is called the hierarchy of controls. As a welder, you may not have control over how the job is done or how the part is designed, so talk with the engineers, planners, and supervisors you work with to see if any of these Chrom-6 exposure controls might work for you. First, let's think about eliminating the hazard. Is there a way to build this part that doesn't require as much hot work? If you can't change the way the part is built, is it possible to use materials with less chromium? Since material composition of the fabricated part is usually dictated by specification requirements, it may not be possible to substitute base and filler metals. However, if specific fillers are being used because that's the way it's always been done, it's worth checking to see whether you can use materials with lower chromium content. If you can't change the way the part is made or the base or filler materials, maybe you can change the welding process. Different welding processes generate different levels of Chrom-6. Generally speaking, TIG creates less Chrom-6 than all types of MIG. MIG pulse creates less Chrom-6 than spray transfer MIG. And hardwire MIG creates less Chrom-6 than flux core. Remember, the work area and air movement will have an influence on your exposure as well. Using video exposure monitoring, we see here that Larry is MIG welding using pulse transfer mode, which is generating low fume exposure even without LEV. His highest peak exposure reaches 5 milligrams per cubic meter, but his average exposure is much lower. If you need to do cutting and you have the choice, use a plasma torch instead of carbon arc. Fume generation during plasma cutting is much lower than during carbon arc cutting, since plasma cutting does not use a consumable rod. The initial cost of plasma cutting may be more, but plasma cutting is quieter by up to 5 to 10 decibels, and it produces a more precise and cleaner cut than carbon arc cutting. Using a cleaner welding process can reduce your Chrom-6 exposure by 60 to 90%. We've discussed the use of local exhaust ventilation already, but what about other engineering controls that can reduce your exposure to Chrom-6? Amperage and voltage often have upper and lower ranges that will work to get the job done. But when the amperage or voltage is at the highest recommended level or even higher, you can increase your exposure to Chrom-6. Decreasing amperage and voltage, when possible, is yet another way you can reduce your exposure to Chrom-6. Filler material, whether it's wire or rod, contributes more to your overall exposure than the base metal. You can reduce your exposure to Chrom-6 by using a wire or rod with a smaller diameter if it still gets the job done. Shielding gas keeps air away from the weld and improves weld quality, but it can also affect the airborne Chrom-6 concentrations. CO2 shielding gas, for example, increases the likelihood of Chrom-6 overexposures. Many weld shops use pure CO2 because it's less expensive, not because it provides the best shielding. An argon blend can provide better shielding and less fume generation and is only slightly more expensive. Using nitrogen gas instead of compressed air for your plasma cutter can reduce Chrom-6 exposures. Nitrogen gas is inert and produces less Chrom-6. There are other gas blends that have been shown to reduce Chrom-6 generation for various welding methods and transfer modes. The components of flux found in stick and flux core arc welding stabilize Chrom-6, allowing it to hang around longer. Research is being conducted to evaluate ways to change flux ingredients to reduce Chrom-6 generation. In fact, there's a lot of ongoing research to explore many different control measures that may reduce exposure to Chrom-6. Your body position relative to the welding operation can influence your exposure. Changing where you stand may be the easiest adjustment you can make to reduce your exposure. As a welder, you've been told to keep your head out of the smoke. Let's put that advice to the test using video exposure monitoring. Here, John shows how different head and body positions can change his exposure. First, John welds on a flat surface in a typical position, about 12 inches above his work. Without LEV, John's exposure is up above the limit. As John moves his head closer to his work at about 8 inches above the arc, his exposure is about 10 times higher. Now, John moves further away about 15 inches above his work. Repositioning his head and body by a mere 3 inches reduces his exposure. Working with your head in the plume certainly can increase your exposure. Flat position welding, while best for weld quality and deposition rates, may actually result in higher fume exposures. Welding overhead may lead to lower fume exposure depending on the work environment, but be careful of ergonomic issues. The bottom line is that any welding position that allows the fume to flow through your breathing zone can dramatically increase your exposure. If you've thought about ways to change the way the part is built, the materials used, the welding process, and have used LEV and found that none of them work to reduce exposures below the PEL, you're required to wear a respirator. Welders often appreciate the use of respiratory protection, as Melissa says here.
But I love my respirator.
If you can't control exposures using elimination, substitution, engineering, or administrative controls, you've got to use a respirator. In some situations, both LEV and respiratory protection may be needed when working with chromium-containing metals. Using a respirator means that your employer will have to comply with the DOSH regulation for respiratory protection. Studies show that stainless steel welders have an increased rate of lung cancer, but these studies did not take into account other exposures to cancer-causing agents like asbestos or cigarette smoke. Remember, if you're exposed to a cancer-causing agent at work, it's even more important to avoid exposure to other carcinogens like cigarette smoke outside of work. Working with a regulated material like HexChEC requires caution and having a plan for safe work. The best way to control your exposure is to eliminate it at the source rather than using a respirator.
Management needs to take the lead to make this happen.